Today, really for only about the next 10-15 minutes, you're going to do this lab activity called Continuing Saga of Organizing Elements. Inside the yellow folder, you'll find this paper. That's your lab instructions. All right, and this is really one of the easiest labs to set up for the year because you just take the instructions and put them on the lab table, and then you literally put the Petri dish right on top, right here, and then add the dots where it goes. That was not a very good looking circle. Now today we will not have starch Ki, so you can just cross that out in your data table there on page number 3. Now what I've drawn over here on the right is kind of the side view. So what you'll do is you'll put all these dots in their places, and I'll just put a couple of bumps around. And then I'm going to put a large one in the middle, and that represents the bleach. Now I'm writing with my fingers, so I apologize if it gets ugly. That one was actually fine. All right, once you have all of these ready to go, and the instructions will tell you to do this, all right? Once all the dots are in there, then you'll take a pipette. Probably going to be ugly. Oh, not that bad. All right, and this pipette will have HCl in it. And you're going to add the HCl directly to the bleach. Now, in real life, you should never do anything like that because it produces chlorine gas, as illustrated in this reaction. Chlorine gas can be fatal and has been used as weapons, but we're only making small amounts, and we're going to make sure once we add that, we put the lid on, all right, and we'll be fine. By the end of the hour, it'll smell a tiny bit like a swimming pool, but really it's harmless to us. All right, so what's happening inside this Petri dish now is that there is chlorine gas floating around. And what happens is the chlorine gas will interact with each of these drops here. And if, it's important you listen to this part right now, if chlorine causes the thing to change color, then chlorine is more reactive than the thing that changed. For instance, let's say you add chlorine to NaI, all right, and that this drop changes color. You would record that change in your data table, and you would now know that chlorine is more reactive that says reactive, just trust me, than iodine. Okay, so if the thing changes, then chlorine is more reactive than it is. Now we can ignore the Na because every single one of these has sodium involved, so we're strictly looking at the thing after the sodium. So go ahead, take this data and use it to answer those questions from the lab. These are the questions that I hope that you are answering. I'm going to go ahead and answer these now. So conclusion question 1, what elements belong to family 7? So in that top experiment, the one you just finished the lab on, that would be the chlorine, fluorine, iodine, bromine. So FCl, IBr, those are the ones we tested. Number 2, rank them from highest reactivity to lowest reactivity. So I'm just going to draw them out real quick. And this, if I was here, this is what I usually do. I'm sorry, once again, I can't be there this week. All right, so the ones that changed were here. So based on what I said earlier in the recording, if chlorine could make these change, then chlorine was more reactive than these two. But fluorine remained unchanged. So chlorine would be less reactive than F. Okay? So what we're going to learn here from this data is that the reactivity of nonmetals increases as you go up. So highest reactivity would be F, and then Cl, then Br, and then iodine. And we didn't test At, but it would be at the bottom. So it would be the least reactive. All right, number 3, how does pH change across the periodic table? We didn't really do that lab. A couple of hours it came in yesterday and we talked about it, but you don't need to worry about number 3. Okay, so hopefully that will help tie some things up, and hopefully the lab went well.